Gentlemen, you can see the formula of confidence interval for mu on your screen. This is what we studied in the previous lecture. If you have any question from this topic, please go ahead. This was the last topic we discussed, the confidence interval for mu when sigma is known. When the population standard deviation is known. In this confidence interval, your upper limit is what? That is x bar plus z alpha by 2 times sigma over root of n, and your lower limit is what? That is x bar minus z alpha by 2 sigma over root of n. Who can tell me what is this? Sigma over square root of n is what?
So the sigma for the C table.
This is the sigma, this is sigma for x bar. This is called standard error of x bar. We also call it simply standard error. This is the standard deviation of x bar. And for the standard deviation of x bar, we use a different word called standard error to differentiate it from the standard deviation of x. When you are talking about the standard deviation of x, you use the word standard deviation. And when you use the same concept for x bar, you use the word standard error. Similarly, in that confidence interval, this z alpha by 2 times sigma over square root of n, this whole thing is called margin of error. And it is denoted by E. And from the formula of Z, if you look at the formula of Z, this E is basically, this is absolute value of x bar minus mu. That is the absolute difference between your x bar and mu. That's the error, kind of error. Just for your interest, if I solve this equation, your E is basically what? Your E is basically z alpha by 2 times sigma over root of n. If I solve this equation for sample size n, because sometimes we are given in the question that the maximum margin of error is this. What should be the sample size for that? Sometimes in the question, and sample size is required. What do we do in that case? For example, construct a confidence interval such that the absolute difference between X bar and mu is maximum plus or minus 0.5. Let me pick a question and I'll show you the question. Let me write a question myself. I can find it. Suppose that for this same question, let me copy it from the top. Suppose that for this question, that the past experience has indicated that the breaking strength of yarn is normally distributed with sigma equals 2. What should be the sample size? What should be the sample size such that we are 95%, for example, confident that the margin of error is within plus minus 0. Let us say 5. So sometimes we are forced to do the backwards engineering. Sometimes we are supposed to find the sample size before picking the sample. And the scientists, they tell us this is our margin of error. We should be within 0.5. So in this situation, what we have is we have a value of E, which is 0.5. This is your E naught. 0.5 is what? This is your E naught. And this is the maximum margin of error you are allowed. That means you are given an equation that your E should be less than or equal to 0.5. Your margin of error should be less than or equal to 0.5. Now you have to solve this thing for the sample size. I'm going to solve it mathematically, but this formula will be given to you in the formula sheet. This derivation, the small derivation, is only for your interest. Now your E is basically, margin of error is basically Z alpha by 2 times sigma over root of n. This should be less than or equal to, I would say, general E naught. I would not write 0.5 here. I'll say general E naught, any value. For this specific question, it is 0.5. If I keep 1 over square root of n on the left side, I'll get, what do I get? E naught divided by sigma Z alpha by 2. And if I take the reciprocal on both sides, what do I get? I get square root of n greater than or equal to, the inequality will be reversed, greater than or equal to E, not E, Z alpha by 2 times sigma over E naught. And if I take the square on both sides, I will have n greater than or equal to Z alpha by 2 times sigma divided by E naught whole square, and this formula of sample size will be given to you in the formula sheet. What I have to do is I have to plug in the three values, E naught, sigma, and Z alpha by 2. Now yesterday I just observed that when alpha is 5%, which is in this question, your Z alpha by 2 is 1.96 is what I used yesterday. So I'll take the same value. I'll not go into the details of how I got this 1.96. Then my sigma is, I think, 2 for this question, and E naught is 0.5 in this question. The maximum allowed margin of error is given as 0.5. So I'll put all the things in the question and I'll get n greater than or equal to 1.96 multiplied by 2 over 0.5 whole square. So I'll get n greater than or equal to what do I get? 4 times 1.96 whole square. 4 times 1.96 whole square. Come again? 61.46. Now n should be greater than or equal to 61.46. N is something that cannot be 61.4656. What is the value of n you will take?
61.
You will take 61 or what?
Yes.
62.
62.
You will take 62 here. Why?
Because 61 at 1.5.
Because if you take 61, you will violate that E naught is 0.5. E naught should be within 0.5. If you take 61, E naught will exceed 0.5. So your n should be greater than or equal to 61.46. And the first integer value after 61.46 is 62. So you'll take the first integer value after this one, after 61.46.
Yes, sir. That's sir.
Yes. Yes, Abdurrahman.
Not. How
Abdurrahman,
did you get a node?
yeah, from the question here.
Yes, the oh. Oh yes.
The question says that the margin of error should be within 0.5 plus minus 0.5.
Okay.
Now I can ask you the same question in 2 or 3 different ways. I'm going to write the statement in all those ways. I can ask you what should be the sample size such that we are 95% confident that the maximum difference between X bar and mu is 0.5. This also corresponds to E naught equals 0.5. You will have the same solution. I can also ask you the same question. Like this, what should be the sample size such that we are 95% confident that the width of confidence interval is 1? What is the width of confidence interval? The width of confidence interval is what? I wrote the maximum limit and lower limit here. This is the upper limit and lowest limit. If you subtract the lower limit from the upper limit, what do you get?
The width.
What do you get?
The width, what is the difference?
The distance between them.
What do you get? If you solve it, what do you get?
2 margin.
2 times margin of error. 2 times z alpha by 2 multiplied by sigma over root of n. So mathematically, width of the confidence interval is 2 times E. So sometimes we give you E directly. Sometimes we give you the width of the interval and you have to divide it by 2 to get E. So if we give you the width of the interval equals 1, that means E is again half. Width is given as 1, which is equal to 2 times E. This implies E naught is again half. So these are 2 or 3 different ways of giving you the value of E naught, the margin of error. And for all these 3 questions, you will have the same solution, n being 62. Now I got a question for you practically. Why I did not take n63? Why I did not take 163? That also satisfies the condition n should be greater than 61.4656. Why I did not take 5000? That satisfies n being greater than 61.4656. That satisfies the condition that the margin of error should be within 0.5. Why I did not go for that value? Why I took specifically the immediate next value 62? Who would like to attempt and answer this question?
Excuse me. we take the lowest end.
Why? That's the question. Why?
The lowest end that will satisfy our condition.
Why? Why the lowest? Amjad Ammar.
Because it's the closest to A.
It's the closest to what?
When we put it in the equation, it gets the closest to E naught.
The question is that the margin of error should be within 0.5, okay? So you have to be less than 0.5. It doesn't mean you have to be closest to 0.5. Yes, you're right that this value will give you E closest to 0.5, but you don't need to be closest to 0.5. You should be within 0.5. So the margin of error should be less than 0.5. Even if you take 1000 sample size, the margin of error will be less than 0.5. But why I did not take 1000? Let me show you. If you take 1000, if you take n equals 1000, your E will be what? E will be Z alpha by 2 times sigma over root of n. So that will be 1.96 times 2 over root of 1000. That will be very small, within 0.5. The condition will be satisfied. But I did not go for 1000. I did not go for 10,000. I did not go for 1 million. Why? Why I took the immediately next value?
Because the percentage of confident need to be 95.
The percentage of confidence will also be 95 here. If I take 1000, it will still be 95. And the margin of error will be 1.96 times 2 over square root of 1000, which is 1.96 times 2 over square root of 1000. That is 0.12. 124, still within 0.5 with the same confidence level, 95%.
Doctor, I think because we're interested in the sample of
We're
population.
interested in the sample size, yes.
Yes, not the population. If we get 1000, we
1000 will still be a sample. Even 1 million will be a sample.
Maybe because in the exam we take the highest value, then it's correct.
Okay, I'll give you an example. If I ask you that bring me an insurance for my car. I want to get a third-party insurance for my car, and I ask you to please refer me or bring me a good insurance such that my limit is, let us say, 700 riyals. I cannot pay more than that. I want a third-party insurance for my car, and my limit is not like this. Let me write it. Let's go to the practical situation. When you are doing the survey in real life, there is a cost attached with observing every unit. For example, in sensitive studies like checking the efficacy of medication, you have to give the medication to observational units, which are patients, and then you have to wait for like 6 months, 1 year, and then you have to take their blood tests to know what was the effect of medication. So for getting this single observation, there is a huge cost involved. not only in terms of money, in terms of risk. You're putting the life of a patient online. So in real life, there is a cost attached with observing every single unit, and you want to minimize that cost. Observing 62 units will have less cost than observing 1000 units. Your condition was to stay within 0.5. So 62 is the minimum value that satisfies your condition to be within 0.5. So I'll go with the sample size that has the minimum cost. In real life, your objective is always to minimize the sample size. That is why the equation you will see is that the sample size should be greater than or equal to this value. So you will take the minimum value that satisfies this condition, 62. I'll not go for 1000, I'll not go for 10,000, I'll not go for 1 million. Of course, the bigger, the better. If I get the bigger result, a bigger sample size, my results will be better. But bigger means what? I have a bigger cost also. Why am I doing the sampling? Because I cannot observe the whole population. I don't have resources to observe the whole population. So my whole objective is I don't have money to observe whole population. That is why I'm picking only a small part of population, a sample. So I have limitations in the cost or availability or whatever. So because of those limitations, I will stick to 62, the minimum possible value of n that satisfies n greater than or equal to 61.46. Anyhow, I'll not go into more details about this one. You will pick the sample size that satisfies that condition, plus it should be minimum. So we pick the first next integer to this decimal point, even if it was 61.001, you would pick what? N equals 62. So you will not round it. Usually you will round it up. Any question from this topic? I told you the three ways we can ask you this question. We can ask you this question in terms of margin of error. I can ask you the question in terms of the maximum difference between X bar and mu. It's the same as margin of error. And I can ask you this question in terms of the width of the confidence interval, which is 2 times the margin of error. Any question?
Yes, doctor.
Yes, please.
Why is it told us that it is 95% confidence, the question?
You have to specify a percentage for the confidence interval, 90 or 95 or 99 or whatever. You cannot be 100% confident. At the end of the day, you are still dealing with the sample, and as long as you're dealing with the sample, you will not be 100% confident. You will only be 100% confident if you are dealing with the population. So even if you take 10,000, 1 million, still a sample. So a percentage will always be attached. A percentage that is less than 100 will always be attached with a confidence interval. And this statement also means that when you create the confidence interval, when you create a 95% confidence interval, the final confidence interval will have a width of less than 1. If you keep your sample size 62 and you create the confidence interval, which is X bar, that was I think 98 plus minus 1.96 times sigma. Sigma was 2 over square root of 62. If you create this confidence interval and you get lower limit and upper limit and you take the difference between the two, you will see the difference will be within 1. UL minus LL, which is W, should be within 1. Will be within 1. That means it will be less than, slightly less than 1. You can check that. You can check that. You can find the upper limit, you can find the lower limit, and you can see that the difference between the two limits will be slightly less than 1. Or this part, the margin of error should be slightly less than half. Nawaf Ali.
Yes, Doctor. If I had like enough resources to do a study or something, so it is fine to go to any value that is within the error range. No matter how big is it. If I can afford it, go to that sample.
If you can afford this, I'll give you an example. If you can afford it, why don't you go and check the whole population? Why you are picking a sample? If you can afford it, go and observe the whole population. No need for picking sample. No need for doing all the statistics. Statistics is basically what? It's the limitation that you cannot observe the whole population.
Correct, Doctor. But I meant like, if you apply maybe a bigger sample, not the population. Maybe the population is like 1 million, but you want to not apply it to 62. Maybe you want to apply it on like, let's say, 500 people.
No, the question is why do you want to apply 500? Your condition was that the margin of error should be within 0.5. So 62 is satisfying that within 0.5. So why do you want to go higher?
If there is no benefit, so it would be better to keep the cost low.
No, if the condition is that you want the margin of error to be within 0.25, then you will go higher. Then you will go higher because the condition wants you to go higher. If the condition does not want you to go higher, you will not go higher, because going higher is like just wasting the cost. And the sole objective of subject statistic is to save the cost of observing all the units of population. We don't have enough cost and resources. So that's the sole objective.
I get it.
Okay, let us move on to the next topic. Muhammad Faris.
Yes, Doctor. I want to ask if the within it means less than or equal.
Within less than or equal. Within is less than or equal.
Okay.
Okay. In the previous topic, what we did was we said there is a population on X. This population is modeled by f of x. This population or f of x has a population parameter mu, and it also has another population parameter sigma square. Both of them are population parameters. And we said this is where we are interested. Parameter of interest. To estimate this parameter of interest, we are assuming this parameter of interest is known. To estimate this parameter of interest, we took a sample from this population, and the size was n, and the sample was x1, x2, all the way up to xn. From this sample, we calculated x bar. That was summation x over n. We said this x bar is point estimate of mu. And then we said we want to extend this point estimate to an interval estimate. So what we did was we added and subtracted something in this x bar, and the single value became an interval, and that something was z alpha by 2 times sigma over square root of n. That was margin of error. And the point estimate became an interval estimate of mu. or we also called it a confidence interval for mu. And while we were creating a confidence interval for mu, we observed that in the formula there is something called sigma here, which is another population parameter. Sigma is what? Sigma is another population parameter. It's the population standard deviation. Now think about this realistically. You're trying to estimate a population parameter mu, and you're assuming that it is unknown. And while estimating, you are using another population parameter sigma, and you are assuming that is known. Is it realistic? So I would say sigma, being a population parameter, it is rarely known in real life. It is very rarely known in real life. So that means this confidence interval that we just created, this one, is a kind of less practical. This is less practical. In this one, we are assuming that sigma is known. You are trying to estimate a population parameter mu, and you are assuming that another population parameter sigma, a side parameter sigma, is known. How is it possible? So this whole formula, this whole procedure is kind of less practical. It's not very practical. Hence, this formula that we started with, x bar minus mu divided by sigma over square root of n, this seems to be less practical. We need, this is the formula we started all the things with, x bar minus mu over sigma over square root of n. We solved this one for mu. We started with this z equals x bar minus mu over sigma divided by root of n. When we solved it for mu, we got a confidence interval for mu that was x bar plus minus z times sigma over square root of n. But here now we got into a situation where we got a trouble with this sigma. Practically, the problem is sigma is not always known. I would say mostly it is unknown. What is the solution? What is the solution of this problem? Sigma is unknown, mostly unknown. You don't have sigma. Still, you want to create a confidence interval for mu. What is your solution? Can anyone come up with a solution? That's the problem. Sigma is practically unknown. You don't have sigma. How can you create the confidence interval in the absence of sigma? When something is unknown, what do?
You try to not use it, like it's substituted with something else.
Substitute it with something else. So in statistics, when something is unknown, what do? How do you substitute it? For example, if my population median is unknown, how do what do I replace the population median with? What alternative do I have? When my population standard deviation is unknown, what do I have? What can I replace it with? If I ask you that I want the standard deviation of the scores of STAT 319 students, all the past students, the current students, the future students, obviously you don't have this sigma. Sigma is the standard deviation in the scores of 319 students, because I don't have all the past, present, future students. So if I want a rough idea about the standard deviation, can you give me that rough idea, or there is no way I can have a rough idea?
You will take the present one.
I'll take the present one, all of them?
No, a sample of it.
A sample of it, and the sample of it will give me what? Omar Adnan.
Can we replace it with the standard deviation of sample?
The standard deviation of sample is what we have available. Exactly, Omar. The standard deviation from the sample is what we have available. So when we replace it with the sample standard deviation in the formula, when we replace the population standard deviation by its estimate, the sample standard deviation, now the resulting thing is no longer Z. Now the resulting variable is no longer Z. This is another distribution which is called T distribution. Z was a standard normal distribution. This is called a T distribution. Now your resulting distribution will be called a T distribution. And if you solve this equation for mu, the confidence interval you will get, solve it for mu, we get x bar plus minus T alpha by 2 times S over square root of n. We get a different confidence interval based on the sample standard deviation. We get a confidence interval where the critical value comes from the T table and not from the Z table. T distribution is similar to Z distribution with an additional parameter V. So when you are going to look for a critical value of T from the table, not only you have to look for alpha by 2, you have to look for the V also. And this V is called degree of freedom. Let me give you an example. For example, I have a sample of size 25, and from that sample I got x bar equals 98 and I got S equals 1.59. And I want a 95% confidence interval for mu. So that confidence interval will be x bar plus minus T alpha by 2 times S over square root of n. I have everything except for this T alpha by 2. I'll start with this T alpha by 2. So for this T alpha by 2, the first thing I need to do is I need to find alpha by 2. That will be 0.05 divided by 2. That is 0.025. Now the first difference between the Z table and T table, in Z table you looked for 1 minus alpha by 2. The T table is already positive side given in the table. So you will not look for 1 minus alpha by 2, you will look for alpha by 2 itself. The second thing you need to look into the T table is V. V is n minus 1 for your question. As long as you are creating a confidence interval for mu, V will always be n minus 1. So V is 90, where is 25 minus 1? 24 is your V. Now you will take these two things, V equals 24 and alpha equals 0.025. You will take these two things and you will go to the T table. Remember, when we went to the Z table, we needed only alpha. And here, when you are going to the T table, you need both of them. You need alpha and you also need V.
I have a
V is
question.
yes.
What is S here and V? Is it always n minus 1?
As long as you're creating a confidence interval for mu, it is always n minus 1.
And S, what is it? V?
It's called the degree of freedom.
Okay.
It is like a parameter of T distribution. Like for Weibull distribution, you have beta and delta. For exponential distribution, you have lambda. This is like a parameter for T distribution. Here I have the T table. And immediately when I paste the T table, you will see the difference. Why I did not take 1 minus alpha by 2 is because it's already the upper tail area given. For the Z table, the lower tail area was given. So I took 1 minus alpha by 2 to get to the positive side. Here in the T table, if you look at the diagram, look at the diagram here, look at this part of the diagram. It's already the highlighted thing is the upper tail area. So you don't have to take 1 minus alpha by 2. You are already on the positive side. So this one is fairly easy to look into. You just have to do what? You just have to look for alpha by 2 in the top column. Alpha by 2 in the top row. And degree of freedom in the first column.
Yeah.
And the corresponding value is your critical value. That's it. This is very easy to look. So your critical value is simply 2.064. Fairly easy to look into. Unlike the Z table where you have to look inside the table and the corresponding value at the edge is your critical value. This is simply a value inside the table where you have to match the alpha by 2 with V and the respective value is your critical value. So I will say my T 0.025 with 24 degrees of freedom is 2.064. I will plug it into the formula and I will get 98 plus minus 2.064 times 1.59 over square root of 24. And I will get a confidence interval. My confidence interval will be 98 minus 2.064 times 1.59 over square root of 24. 97.33 all the way up to 98.67. So you will say we are 95% confident. Same statement. Confident that the average. What was the variable? The average. Where is my variable? The average breaking strength of yarn. The average breaking strength of yarn belongs to this interval 97.33 to 98.67 psi.
Excuse me, doctor.
Yes.
We only use the T table. If sigma is unknown?
We use t-table when sigma is unknown.
Okay.
Ali Al Hassan.
Yes, Doctor, for the formula, I think it is square root of 25.
It is
Square root of 25.
formula. Where is? Yes, square root of 25. Yes, yes, thank you. Thank you, thank you. I think the answer will also change. Did I take 24? Yes, I took 24. Should be 25. 6, 6. Slightly change. 3, 4. Yes, the formula is 25, square root of 25. It's n, not n minus 1. Inside the t critical value, you will look for n minus 1, but in the formula you have n. Any question?
Doctor, the value of u given or I can calculate it?
I did not get the question. Can you speak a bit loud?
The value of u.
The value of mu?
U.
U?
Yes, or v.
V, not u. It's v.
Yes.
The value of
It is
v
different.
is n minus 1.
N minus 1.
Yes, that's the formula of v. V is always n minus 1. Any questions?
Doctor, regarding the PSI, can I take the average of the two numbers and write it? Is it okay, or should I give the two numbers?
Regarding the unit, PSI is the unit.
No, I mean like 97.34 and 98.66. If I take the average of them and give it, is it okay? And use it like for further calculations, is it okay or not?
It's a very interesting question. Now, look at this. This is a real line from minus infinity to plus infinity. Now stay with me, Saud. You had this x bar somewhere, and you are trying to estimate an unknown quantity which is somewhere between minus infinity and plus infinity. I don't know if it is above x bar or below x bar. I don't know. It is somewhere. Okay, it is somewhere. Now you said that, let us say mu is somewhere here, which we don't know where it is. It can be on the left side, it can be on the right side. Now you said that the point estimate x bar, this is a point estimate of mu. It is rarely equal to the mu. It's always either on the left side of the mu or right side of the mu. So you are always wrong. When you say x bar is the estimate of mu, you're always wrong, sometimes by a small margin, sometimes by a big margin. So there is a need to extend the point estimate to an interval estimate. How do you extend a point estimate to an interval estimate? You add something in x bar and then you subtract something in x bar. When you add something in x bar, you go to the right side and you get x bar plus z alpha by 2 multiplied by sigma over root of n, or t alpha by 2 multiplied by s over root of n. And when you subtract something, you go to the left side and you get x bar minus z alpha by 2 times sigma over root of n. So did you get the point up to this situation? What I'm trying to explain?
Yes.
Okay,
yes.
Now you get the interval, and about this interval you say that we are 95% confident that the interval will contain mu. And yes, 95% of the times, if you create 100 such intervals, 95 of them will contain mu, 5 of them will not contain mu. Now Saud's question is, instead of reporting these upper limit and lower limit, this is your upper limit, this is your lower limit, Why don't we report the average of upper limit and lower limit? Who can tell me what will be the average of upper and lower limit? What will be the center of upper and lower limit?
X bar.
X bar itself, the point estimate itself. You are going back towards X bar if you are taking the average of upper and lower limit. Average is what? Average is the center, and the center of two values is again X bar. You go back to the point estimate.
I get it.
You
Thank
got
you,
it?
sir. Yeah, thank you.
You can also see this thing in exam. We give you not much information and we tell you that the upper limit and lower limit is this one for the confidence interval. What is the center of the two? What is the value of X bar? So if we give you UL equals 76, LL equals 56, and we ask you to give us X bar. X bar is what? The center of these two. 56 plus 76 over 2. X bar should be middle, 66.
This is a nice
that was an interesting and good question. And that was something related to exam, something you can see in exam, that we can give you the confidence interval and ask you for the point estimate. Give you the interval estimate and ask you for the point estimate. You just have to do what? You have to look for the middle of the interval estimate. Yes, someone was asking a question. Okay, any other question? Yes, South.
If you have finished the class, I want to ask about the quizzes. Are you willing to give us quizzes before the midterm or after the midterm?
No, of course before the midterm. There is no point of giving the quizzes after midterm. Midterm is on 12th. So quizzes will start after tomorrow, 8th. 8th, or I should make it 11, 12. Yes, it will start on 8th. 8th. Do we have a class on 10th?
Doctor, we have Saturday classes.
We have a Saturday class on 10th?
Yes.
We can have it on 10th, 11th, and 12th.
Doctor, can we have it in 8? How many quizzes will we have?
I want to take 3. I want to take 3.
3 before the midterm?
3 quizzes, 3. 1 from chapter 2, 1 from chapter 3, 1 from chapter 4 and 7.
So it's like a review.
Yes, it is like a review. It's like a preparation for exam.
Doctor, can we make it to like an 8 and 10th?
I want to take maximum number of quizzes so that by the end of the semester I have like 6 or 7 so that I can delete more than 1. If you want, I can take 2.
It's
I
good
will take
if you
2
have.
by the end of the semester. I will have exactly 5 quizzes and I will not delete any worse quiz.
No, we need more quizzes. It's fine.
That was the thinking. I want to take 3 so that I can take 3 more after the midterm exam, or maybe 4 more, so that by the end of the semester, if I have 7, I can delete 2 and take the best 5.
Okay.
So let's plan it like 3 kind of 10th, 11th, and 12th. And the quizzes will be like 20-25 minutes quizzes, and the remaining time of the class, what we will do is we will. Do you guys know I'm posting practice questions on the Blackboard?
Yes, which from the
Yeah, we see it.
Who's trying to solve them?
I tried a couple of them.
I did not receive any request that I was unable to solve this one. Give me the solution or guide me to solve. I have the solution for them. I'll keep it on hold, and I will post it maybe 1 day before or 2 days before the exam. Before that, better you solve it yourself.
Doctor, the summer term is very quickly. Even though we